We're going to have a chemistry unit test tomorrow, so today we're doing a test review. So let's talk about parts of an atom first. The three main parts are neutrons, protons, and electrons. The neutrons have no charge. They're fairly large. They're in the nucleus. They're in the middle of the atom. Protons are also in the middle of the atom, and they're fairly large, but protons are positive. P proton, P positive. Protons are positive. Electrons are very small, and they have a negative charge, and they're on the outer part of the atom. The outer part of the atom. These are the three major parts of an atom. So again, protons are positive. They identify what type of atom it is. Protons are very, very important. Neutrons, they do not have a charge, but they're also in the nucleus, and both protons and neutrons make up the mass of the atom. Electrons are in the electron cloud, and they circle around the outer parts of the atom. They're the outer part of the atom. The nucleus is in the inside, in the middle, and it contains 99.9% of the atom's mass. This is where the mass comes from. And the nucleus has protons and neutrons in it. So basic parts of an atom, the three main parts. We have protons. They're positive, and they make up the mass of the atom, along with neutrons. Neutrons have no charge, and they also make up the mass of the atom. Okay, protons and neutrons, they make up the mass of the atom. Then we have electrons. They're negative charged. They're in the outer part of the atom, in the electron cloud. So the nucleus is the center part of the atom where the protons and the neutrons are located, and that makes up the mass of the atom. About the periodic table, there's a lot going on in the periodic table. Almost every periodic table up here has one of the element boxes out here to show you what everything means. The number at the top is usually the atomic number, atom. It helps us understand what type of atom it is based on this number. Okay. The element symbol, it's either one or two letters. If it's one letter, it's capitalized. If it's two letters, the first one is capitalized and the second one is lowercase. And this bottom number is the atomic mass. It's the mass. This is the protons and neutrons in the middle. 8-man. So there's a lot that the periodic table tells us, but there's some things that it doesn't, and we have to try and figure things out. Okay. The atomic number, the small number at the top, is going to tell us how many protons there are in this atom. And according to 8-man, this A atomic number, A stands for atomic number, that number is equal to the amount of protons and that same number electrons. So for this carbon atom, the 6 up here tells us there's 6 protons, 6 electrons. Okay, atomic number A, there's 6 protons, there's 6 electrons. All these numbers are the same up here for 8. Okay, P is for protons, E is for electrons, and that is what the atomic number tells us. So now let's look at the atomic mass. This is the center of the atom, in the nucleus. So it's the protons and the neutrons. These are the large parts of the atom. Okay. Mass tells us how many protons and neutrons together there are in the center of the atom. It doesn't tell us the number of neutrons, though. Okay, this tells us it's an average number, because there are some atoms that have different numbers of neutrons, but we're talking about a stable atom, like a stable carbon atom. This information, nothing here tells us how many neutrons we have. So we have to figure this out by doing the MAN part of 8-man. M stands for mass. M is mass. A is the atomic number again. Okay, this number here. So the mass for carbon is down here. This is the mass, and we would round it to the nearest whole number, so it would be 12. The A is the atomic number. That's up here, the 6. And that would tell us how many neutrons. So it would be 12 minus 6. So there should be 6 neutrons here. Okay? You round to the nearest whole number. You minus the atomic number. And that tells you how many neutrons. Okay, so let's look at this here. We have the carbon atom. Okay, there are 6 protons in here, and sometimes we can't count them, but this also means that there's 6 electrons. 1, 2, 3, 4, 5, 6. Okay, and based on 8 man, we just did that, there are 6 neutrons. There should be 6 neutrons here. So let's practice this. We have an unknown element, or an unknown atom. Let's see. We can't really count how many protons because I don't know if there's some hiding in the back or not, but we can definitely look at the electrons. There's 1, 2. There's 2 in this first energy level. And then this outer energy level, we have 1, 2, 3, 4. So total we have 6 electrons. And for 8 man, if there's 6 electrons, that should mean there's 6 protons as well. And the atomic number should be 6. Okay, so there's 6 electrons. 6 protons. But we don't know how many neutrons, so we have to do man, M-A-N. So the mass minus the atomic number will tell us the amount of neutrons. But we don't know the mass. What is the mass? We don't have that information here, so we need to go look at the periodic table. So if you go look at the periodic table, you can look for the number, the protons, that's going to tell us the atomic numbers. So you go look for the 6, okay, and that will tell you that is a carbon atom. And carbon has a mass of 12.011, which we are going to round to 12. 12.011. It's going to be rounded to 12. So we would minus mass and atomic number, and then that would tell us the number of neutrons. 6. So this is carbon. We just did this one. Okay, so let's look at this one. What type of atom or element is this? Let's do 8 man. So I'm not sure if there's any hiding behind here. I don't think so. So let's look at the electrons. We have 1, 2, 3. We have 3 electrons, so that means there's 3 protons. That means the atomic number is going to be a 3. Okay? And if you look on the periodic table, that tells you we have the atomic number 3 means lithium. How many neutrons? So if we only have the mass and we only know the number of electrons, how can we figure out how many neutrons? Well, for ape, APE, we know the number of electrons right here. So that means that's the same number of protons, and that's the atomic number. So the atomic number is going to be 27. It's going to be 27 protons. So if you look at the periodic table and look for 27, that should tell us what element it is. But that's not the question. We want to know how many neutrons there are. So we have to do man. So we have the mass, it's 59, minus the atomic number, which is going to be the 27, because there's 27 protons. So that means that's the atomic number. So 59 minus 27 means there's 32 neutrons. So again, with the same information, mass is 59, electrons 27. What is the atom? Okay, so if we go back to ape, atomic number equals protons equal electrons. Well, we know the electrons are 27. So the protons are 27, so the atomic number is 27. So if you look at the periodic table, we should go see what atomic number 27 is. And that would be cobalt, 27 right here. What is the mass? What is the mass? You remember in the very beginning of this, we talked about where most of that mass comes from in an atom. And it's going to be the protons and neutrons. Protons and neutrons. That's where the mass comes from. Okay. So the mass is 39. And because there's 19 protons, 19 electrons. That's our atomic number. So if you look at the periodic table, atomic number 19, that's potassium. Counting atoms. So this is only a capital letter all by itself, so that means that is one type of element, that's carbon. We have a capital O here, so that's oxygen. And we have this subscript right next to the O. That subscript goes to the O, or to the oxygen only. It does not go to the carbon. It goes whatever is next to. So we only have one carbon. There's an imaginary one here. And we have 2 oxygen. So let's look at this next one. Now we have a subscript and a coefficient. So this right here, H2, that means there's 2 hydrogen atoms bonded together. Okay, so that makes a molecule. There's 2 atoms, 2 hydrogen atoms bonded together. That is a molecule. But the coefficient is telling us that there are 5 molecules. So there's 5 of these. So how many hydrogen are there? Well, if there's 2 in every molecule, and there's 5 molecules, we'll multiply that by each other, and then that means there's 10. 10 hydrogen atoms altogether. Okay, so for this next one, carbon, the subscript means that there's 2 carbon atoms, but the coefficient in front of it, it's telling us that there's 2 of these molecules. So for this carbon, it's 2 times 2. So there should be 4 carbon atoms. And for hydrogen, there's a subscript of 6, but there's also a coefficient of 2. So for hydrogen, it's 6 times 2. So that means there's 12 hydrogen. Okay. Now for this one down here, we have sodium. There's 2 letters for this one, a capital letter and a lowercase. That means that's one element. That's sodium. Subscript says there's 2 sodium atoms. The coefficient in front of it means that you need to multiply that by 2. So for sodium, there should be 4 atoms of sodium. Sulfur, there's an imaginary 1 right here. That means there's 1, but there's a coefficient of 2, so that means there's 2 sulfur. And for oxygen, there's 4, but a coefficient of 2, so that means there's going to be 8 oxygen. Okay. I'm going to have these Google Slides in our folder, so you can come and watch this video to recap on how to count atoms. Let's move on to chemical equations. Chemical equations means that there was a chemical reaction. On the left side, we have the ingredients, or what is formally called the reactants. That means there were molecules that started the chemical reaction. This is after the chemical reaction. These are called products. Okay, so the atoms or the molecules started off as we have 6 carbon dioxides and 6 water molecules. Then we had a chemical reaction, which means the atoms rearranged themselves to make something new. So this molecule here is a glucose. Okay, there's an imaginary 1 here, so this is 1 glucose molecule. And then we have 6 oxygen molecules. So we're counting atoms. So let's focus over here for the reactants. Okay, first list out your elements. Okay, I'm going to hide this coefficient just for now and just count the molecule for carbon dioxide. And then I'm going to go ahead and multiply it. There are 6 molecules of carbon dioxide. So that gives me 6 atoms of carbon, 12 atoms of oxygen. So now I want to work over here on the water. I'm going to hide the coefficient for now. There's 1 oxygen. Then we start working on the coefficient, which tells us how many molecules there are. So now there's 12 hydrogen and 6 oxygen. If we simplify these together, we have a total of 6 carbon atoms 12 hydrogen atoms, and 18 oxygen atoms. So let's work on the products. Write out your elements. We have carbon, hydrogen, oxygen, and then we have also another oxygen. 6 carbon, 12 hydrogen, 6 oxygen, and then we work on the oxygen molecules. Let's hide the coefficient for now. We have 2 oxygen, okay, and then multiply by the coefficient because there's 6 oxygen molecules, and that leaves us with 12. And if we simplify the products, we have 6 carbon, 12 hydrogen, and 18 oxygen, which is the same as the reactants and the products. They match up, so this is a balanced equation. So let's work with mass. So in this chemical equation, we have 2 hydrogen molecules, we have an oxygen molecule, and then after the chemical reaction, we have 2 water molecules. This is the chemical reaction part right here. This is the product. These are the reactants, okay? We have the total amount for the product. And the law of conservation of mass says whatever we end up with is what we started with. Whatever we started with is what we end up with. So the reactants should match the product side. So this is basic math that you have to do. What is this missing amount? So you find the difference, and the hydrogen atom should be 12.10 grams. Periodic table categories. We have metals, nonmetals, and metalloids. Metals are shiny, mostly shiny, most are hard. And then we have nonmetals, most are not shiny and they're brittle. And then we have the metalloids, which take characteristics of both sides. Groups and periods. So we have groups that are vertical, and they tell us the valence electrons, the amount of valence electrons. So this first group, there's 1 valence electron, very reactive. Group 2, there's only 2 in the outer energy level. There's 2 valence electrons. Group 3, 3 valence electrons. 4 is 4 valence electrons, and so on and so on, all the way up into 8. 8 is great. 8 is a very stable atom. 17 wants 8, so it's constantly trying to grab 1. So 17 is very reactive as well. 1 is trying to give its atom away, so it's very reactive. Groups are sometimes called families because, like families, there's common characteristics. So all of the elements in a group have very common chemical properties. So hydrogen, lithium, sodium, potassium, they're all very reactive. Over here at 17, fluorine, chlorine, bromine, they're all very reactive. Okay, so if we have this example here, group 1, it's because it only has 1 valence electron. This is a very reactive atom. Then we have periods. Periods go across. It tells how many energy levels an atom has. So period 1 only has 1 energy level. 2 has 2 energy levels. 3 has 3. 4 has 4. And we don't really go past 3, but all the way down to 7, it would be 7 energy levels. Okay, we start with the closest to the nucleus is the first energy level, then the second goes the outer, and the more energy levels, the further out they go. You can use the periodic table like a graph. For example, what element has 2 energy levels? So we would look here at the periods, 1, 2, 2 energy levels, and 5 valence electrons. So it would be this row here, this period. 5 valence electrons, we would go to the 5th one. So 1, 2, 3, 4, 5. Okay. 2 energy levels, row 2, period 2, 5 valence electrons. And that would be nitrogen. Evidence of chemical reactions. So an example would be if you put vinegar and baking soda together, you have a chemical reaction. And how do you know there's a chemical reaction? Well, there's a list of evidence that we look for. For here, there's bubbles, it's fizzing. So that is one of the evidence pieces. So we have new color. If the color changes, that is evidence. Bubbles are fizzing, that means gas is being released. That's evidence. A precipitate, that means a solid formed. That's evidence. If heat is released or absorbed, that is evidence. If light is produced or a light emission, sound, and if it's really, really hard to put back to its original state, that's also evidence of a chemical change. This is an example of sodium and water. There's light emission and gases being released. So there's two pieces of evidence, chemical reaction. Then we have another one here that a precipitate is formed, and also a color change.